So again, Chapter 2 starts on page 47. What I often get, especially with newer students, is people will say, is this important? Is this going to be on the test? Do I have to memorize this? All right, you'll know exactly what you have to memorize for the written test tomorrow, because we will go over the test review tomorrow for taking a test Wednesday, a written test for Chapter 1. I'll give you the entire test, so you'll know exactly what it is you have to memorize. All right. Chapter 2 talks all about different kinds of variables. Now, when you see here integral and floating point types, these two right here, that means those are numeric variables, these two. Arithmetic operators, guess what? You know what 4 of the 5 are. Plus, minus, multiply, divide. All right? Plus is your, what you're used to, it's the plus sign. Subtraction is the minus sign. Multiply is an asterisk. Divide is a forward slash. The only one that you may or may not be familiar with is the percent sign. That's the modulo or remainder operator. So if I say 6 modulo 4, well, the answer is 1 remainder 2, right? So the answer for modulo would be that, the 2. Those are the arithmetic operators, all right? You've got bool. Bool means true or false. Quite often, if you create a variable that's a Boolean variable, you start it with the word is. Is union, is married, is of legal age, something like that, because those are true, false. Numeric type conversion we'll get into in just a bit. Now, I want to show you something on the board here just so you all see it. Because if you remember from last semester, those of you who were in the class, you could say this. Var age, not age, that's a terrible one. Var name equals, double quote, Jeff, double quote. Or you could say var name equals, double quote, single quote, Jeff, single quote. All right, what I want to tell you is you can't do that in this language. If you make a string, it has to be put in double quotes. So here you would say something like string F name for first name equal Jeff. Does that make sense? If I want to use a character, it's like char mi for middle initial equals single quote P single quote. See the difference? So strings are within double quotes, chars are within single quotes. All right? We'll also talk a little bit about constants and enumerations, and then how to accept console input. Okay? All right, so you'll see all that stuff in here. We probably won't have enough time to get through the whole chapter. If we don't, not a problem. We'll finish it up tomorrow morning and then get ready. So if you're still loading that package, hopefully it'll be loaded by tomorrow. Don't worry about, just have your computer on. You don't have to start Visual Basic. You don't have to do a flaming thing. But just be ready, because if we do get done with 2, tomorrow we're going to write a good half dozen programs. All right? And you're all that good. I don't care if you're brand new. You're all that good. And the way that I work is we're not going to go on if somebody has an error in the program. I'll walk over there, try to help you with it. All right? Now, maybe you've heard me say this story before. I always remember this. When I graduated and got my second degree, I went and got a job, and I was a programmer. And I had a car that basically sucked. All right? And I kept it for a couple of years until I could afford to get a better one. All right? And I had this guy who was my mechanic who I got to know really regularly. And I was always amazed that I could come there, and in 5 minutes, he could figure out the problem. And since he was a friend, he usually charged me very little. And I told him that one day. And he just laughed. And he said, it's all practice and experience. He said, I couldn't sit there and program things like you do. I could never do that. The reason I'm telling you that is, especially if you're brand new at this, it's expected you're going to make mistakes. That's how you're going to learn anyway. But ideally, what will happen is you won't keep making the same mistakes. All right? All right. So, a constant you'll see in just a minute, that's something whose value cannot change once it's been set. If I do this, if I say, do they show, no, they don't show an example here. I showed you this before. So if I come in here and I type in here, don't worry if you can't even see it that well, but if I type in int age equal 21, this value right here, that 21 that appears on the left-hand side of an equal, I'm sorry, the right-hand side of an equal sign, that's called a literal constant. I can't change that. I could put a different number in there, but I can't change 21. A literal constant like that can never appear on the left-hand side of an equal sign. I can't say int 21 equal age. Doesn't make any sense to the computer. A variable, again, named memory location. We already looked at that. Unlike JavaScript, in C#, when you create a variable, you got to give it a type. You have to. And you can use the word var in C#. It means something totally different. So let's just not just pretend it doesn't exist until we get much, much later in the book. All right? Now, if you look here, and I don't have the time or the patience, but if you look, this is page 49 in your book. And it says, if you create something that's called a byte, it has the ability to hold a number between 0 and 255. If you say S byte, all right, it's between negative 128 and positive 127, etc. Virtually all the time in here, for whole numbers, we're going to be using an int. Almost always. And notice it's got a range of 2 billion on the negative side to 2 billion on the positive side. That should handle anything we have to do. All right? And virtually all the time, when we have numbers that have decimal places, almost always we're going to use doubles. You don't have to worry about the rest of them. You never will have to worry about, well, geez, what is the largest value I can hold? Who cares? All right? I want to say something now. JavaScript, that those of you who were in the class last semester learned, that's called a loosely typed language. We never, ever, ever associated a data type with a variable. C# that you're learning this semester and you will use next semester, and Java, which you will use your last semester, those languages are all strongly typed. If I leave the int off here, I get an error. If you don't believe it, take a look. You've already seen this. All right? The name num1 does not exist in the current context. The system doesn't know that that is an integer variable. It doesn't know that because I didn't give it a type. All right? You can look at it any way you want. I broke the rules, whatever you want to say. Whatever, is easiest for you to understand. All right, so when you declare a variable, this is, I said this to you guys last semester, but I want to say it again. I want you to understand this, especially if you're a new person. All right? If I do this, that's called a variable declaration. If I do this, that is a variable initialization. If I combine them, that is both a variable declaration and an initialization. So you can do them as one line or two lines. And you might say, okay, I get that. Why would you ever want to do it in two lines? What if I'm writing a program, and let's say I've got three classes. Let's say I'm at in a university, and I've got three classes. One that's in a lecture hall, one that's a fairly big group, and one that's a small group. So let's say I have 10 people in one class, 50 in another class, and 500 in another class. I might want to ask here, so I might just want to create a variable that's called int num students. But then in between these two things, I might want to ask how many students are in this class. All right? Then I could set the value of that to this. So again, it always depends on the context in what you're doing, something. So when you create this and you do something like this, where we both declare it and initialize it, the data type, the name of the variable, and this part is optional, but this is equal 25. Now, just so you know, equal sign like that is the assignment operator. You and I would read this as int my age equal 25. That's what I'd say. Literally what it means is take the number 25 and assign it to the integer variable my age. Now, no one talks like that, all right? But that's the way that the computer looks at it, just so you are aware of that. So a single equal sign means assignment. You can do this where you are creating multiple variables on the same line, unless you're in my class, because I don't like that. So if that's you, I want you to write int my age equal 25 semicolon, int your age equal 19 semicolon. The reason I want you to do that is when you declare variables, you really should put a comment after them explaining what the variable is. All right? I mean, this, my age, your age, isn't bad. All right? And I want you to use good names for your variables, but you'll see all this stuff starting tomorrow. Notice here the author says, watch the video declaring variables. Remember earlier I showed you this? And I said that you can go out there. That's not there. Of course, so I closed it. All right, and I said there's the author's website. Those are the videos that we're talking about. She usually has one or more videos for most every chapter. If you like, if I want you to learn the stuff. If you learn it better by looking at her videos, go ahead and do it. They're not nearly as long as mine are. I'll tell you that right now. This one's already up to 12 minutes. I don't think she has one that's more than 5. Could I be wrong? It wouldn't be the first time. All right. So you've already seen this Readline thing. We're going to do it tomorrow, so I'm not going to spend a lot of time on it. Just so you know, there's both write and Readline. Everybody hear what I said? There is write and there's Readline. The difference is when you do a Readline, it puts a blank space under it. In other words, it's like you hit enter after you did it. With write, it stays on the same line. Okay? You're going to do this tomorrow. So if that doesn't make sense, hopefully it'll make a lot more sense after tomorrow. And when I say that stuff, if it is tomorrow and it doesn't make sense, you have to ask. I think that one thing everybody in this class who was in here last semester would agree. I'll typically, before we go on to something, I'll say, does everybody understand that? But again, no joke, I'm not clairvoyant. So if you don't get it and you don't say anything, I have to assume you do get it. All right? This character right here, in this case, this plus sign, that doesn't mean add. It means concatenate. Glue things together. So if I had a variable called first name that had Jeff in it and a variable called last name that was called Scott or had Scott in it, and I said I created another variable called full name, I could say equals first name plus last name. Boom, it would be Jeff Scott. All right, again, you're going to see this tomorrow. You're also going to see these placeholders, and a lot of times this drives people nuts. If you look at this right here on the screen, this may be the hardest part of this chapter. This 0 that's in here is a placeholder. For what? For this. So it's going to take whatever the variable is for some money, and it'll put it in there with a $sign. So you know that. You're going to see that tomorrow, and then we're going to say, wow, is there a better way of doing it? I'm going to show you other ways of doing it. I'm to the point where, when somebody says, is that the best way of doing it? That's almost not a fair question because you're asking me to impart my values on you. I can say, in my opinion, yes or no, but I am no authority on anything. All right? So we'll write a few of those tomorrow, okay? And then they tell you how you can format things. Let's not worry about that right now. So if you want to put some spaces in, etc. All right, then they talk about the int. And you'll notice if you look right here, an int is a number that cannot have a decimal place. Everybody hear that? Int is short for integral. So 53 is an int. Pi, 3.14159, is not an int. If you try to create an int, just so you see this. So if I come in here and try to create an int, let's get that. Notice the error goes away now. But if I say 10.6, now I get another error. It says cannot implicitly, the system doesn't know how to go and take this and put that into a whole number. So how do you do that? Well, I can remove the 0.6, right? Isn't that the easiest way? Or I can come in here and do this. I can put in here int, like that. That's called a cast. We'll get into that tomorrow or the next day. All right? So there are several kinds of ints. The difference between these, if it starts with S, like S byte, or that's a short byte right there, or I'm sorry, that's a signed byte. If it starts with U, like U short, U int, U long, those are all what are referred to as unsigned. That's what the U stands for. All right? And it looks weird. It's like, wait a minute, char. You just told us when we did char, it was like char mi equals single quote, p single quote. How can that be an int? Because you can actually do math with characters. Okay? So if I said my first character is A, and I added 13 to it, it would be B, C, D, E, F, G, H, I, J, K, L, M, N. Then it would now be N. All right? You don't normally do math with chars, but you can. Certain times there's a reason for actually doing that. So they've got a program they have you do in here where you work with some ints. All right? Now, before we go on to the floating point, I just want to mention to you, I am going to give you my own programs that we're going to do as a class. We're going to start this tomorrow. Many of you have done a lot of this stuff already. It's going to look very familiar to you, but we're going to use a simple payroll system that we're going to keep writing and rewriting and tweaking. You won't have to turn those programs in. Did you hear that? But they probably will help you to have them and have them working, because when we do an actual hands-on test, there'll be similar types of programs. All right? A floating point number is one that can contain a decimal place. There's three main types of floats. I'm sorry, of floating point types. Now I want to show you all three of them in here because it looks weird. So let's say I wanted to create a variable that was called pi. I could say double pi equals 3.14159. Works just fine. All right. And what is it doing here? Int. Oh, let me just get rid of that line. It doesn't matter. This would just have to be a double. Now it'll work. All right. Yeah, make me a liar. The name num1. Oh, it's because I got rid of num1 equals pi minus num2. All right. That would work. Okay. Now, so what's the difference? What if I put float here? Not do float, obble. What if I put the word float here? What's going to happen is I'm going to get an error. If you use floats, when you initialize them, you must put either a lowercase f or a capital F, which means float. No programmer that I know of uses floats for that reason, because they have to type F there. They just don't like doing it. All right? What if I was doing this? What if I was doing, I want to say here, decimal, and I'm going to call it pocket change. So that's how much change I've got in my pocket. And I'm going to say, let's say I've got 85 cents, 0.85. Notice it doesn't like that. Well, how about F? Doesn't like that either. Because if you're working with decimals, you have to put in an M. Somebody asked me once, they said, what does M stand for? Not sure. But the D is already being used for double. All right? That's why I think they don't have you put a D in there, because you might find that confusing. So the float and the double, what's the difference besides the F? Notice it says the float is only guaranteed to be accurate to 7 digits, whereas a double is accurate to 15 digits. All right? So that's 9 digits before the decimal point and 6 after. This is 4 digits before and 3 after. Okay? And if you say, what do you mean by that? You're going to see it as we go on. The decimal is what you typically will use, all right, if you're working with dollars and cents. I decided not to even in the thing that we're doing, we're not even going to use decimal. All right? I'm just going to use doubles. Wow, they use pocket change. I didn't even know they did that. Maybe that's where I read it from. You can also work with scientific notation or e-notation. I don't care. Unless you're a scientist, you probably don't care. All right? Now, when you print stuff out, you can format it. And these are some of the format characters you can use. Notice if you want to format something for currency, it's a little c or a big C. Formatting it for decimal, it's a little d or a big D, etc. All right? Notice if I format it for currency, the system will automatically add the dollar sign for me. It'll automatically add the commas if needed. It'll automatically add the period, 00 or whatever in there for me. So that's kind of nice that it does that kind of stuff. We will take advantage of that. Here's your arithmetic operators. I already showed you the remainder. I'm asking the two of you, does everything up there make sense? All right, I showed you what the remainder one was. People say to me, well, why do you use remainder? I'll give you 2 major times you will use remainders. If you're given a number of cents and you want to break it down, so if I say, how many dollars is 10,563 cents? All right? You could do a bunch of modulos and a bunch of divides to figure out exactly how much it is. So the other time you use it is when you're working with how many seconds, how many hours, minutes, and seconds are there in 57,312 seconds. You could use a bunch of divides and modulos to figure that out. All right? Operator precedence. You remember this from back from junior high or whatever? You do multiplication and division before you do addition and subtraction. If you want to change that, you use parentheses. If in doubt, use parentheses. All right? All right. These, I just want to show you them very well. I'll show you it on here. Let's get rid of all this. We'll just keep num2 in here, and I'm going to get rid of the other lines that are in here. All right. If I wanted to put in here, if I literally wanted to put in here, let's say I want to add 5 to num2. I can say num2 equals num2 plus 5. Totally legit. Not a thing wrong with it. Fine. A shortcut to doing that would be to say num2 plus equals 5. So those 2 lines do exactly the same thing. Does that make sense? It's just a shortcut. I will tell you that new programmers often do this. Experienced programmers never do that because, as you can see, you're saving yourself a few lines of typing. So there's a plus equals. There is a minus equals. There is a times equals. There is a divide equals. And there is a modulo equals. Okay? So all of them, all they are just shortcuts. I've oftentimes said this, you can attest to this, I said it last semester, I'll keep saying it. Especially if you're in the first year of a 2-year program for understandability. If it's easier for you to use the first line, I will never, ever take off for that. If you're out in the field and you program like that, people are going to laugh at you. It's like, don't you know there's a shortcut for that? How do I know that? Because when I was out in the field and didn't know about the shortcuts, they laughed at me. All right. What if I want to do this? I've got two variables here. Int, in fact, let's make this num1 again. And this will be num2. And I'm just going to set it equal to 0. Now, if I do this, num2 equals num1, I'm asking you this because I don't know. Does this make sense to everyone that when I get done with this, both those are going to have the value of 7 in there? Does that make sense? I'm taking 7 and assigning it to num2. Okay? But I want to show you something. If I do this, and this plus plus and minus minus that we're going to look at next only let you add 1 or subtract 1 from a variable. This line right here, this line, is the same as if I said num1 plus equal 1 or num1 equals num1 plus 1, and then I said num2 equals num1. This is called the pre-increment operator. It means add 1 to this and then assign it here. All right, it's called pre-increment. Add 1 to this and then assign it here. So when I get done doing this, num2 will have the value 8. That makes sense? If I do it the other way, so if I were to say num2 equals num1 plus plus, that's as though I took these two lines and flipped them. So what I do here is I take what was in num1, which is 7, and I assign it to num2. Then, all right, then I add 1 to num2. Maybe I did it backwards. I don't know. But the point is, if I do this one when I get done, all right, now num2 will have a value of 7 and num1 will have a value of 8. All right, you're going to see these tomorrow. So if I confused you, you're going to see them. Typically, you know, if you say, wait a minute, Jeff, I sort of understand, but it's a hell of a lot easier for me to actually type in 2 lines of code, all right? So it's much easier for me to type in these 2 lines of code and understand it than it is to type in this, then type in 2 lines of code. But there are a bunch of shortcuts that you're going to see as we go on in here. That's what I'm telling you. All right, so there's add and assign, subtract and assign, etc., plus equal, minus equal. Then there's the prefix and the postfix. I just showed you all of those. And not only can you do plus plus, you can do minus minus. Don't ever, 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 ever do this. Well, I wanted to add 7, so I did plus plus with a 7. No, it only works to add, or if you want to, subtract 1. That's it. This isn't typically how you'd use this. When we get into loops, which are in about chapter 4, that's typically when you use these. All right? So we'll talk about them in more depth and breadth of coverage when we get to that chapter. Bool, as I said, are true, false. Notice, is it Monday? Well, that would be true for us. Those are the only 2 values a Bool variable can have. True or false. True must be in all lowercase, false must be in all lowercase, and it's the word bool. In other language, it's the word Boolean. If you don't know or if you don't care, but just so you know, there used to be a mathematician named George Boole who thought of these kinds of variables, and that's why Boolean is named after him. Here are your comparison operators. I don't know if you remember this before, but I just showed you this. And I said, this is called the assignment operator right there. All right? If I want, if I do this, if num1 equal num2. Notice how I get a bunch of errors there? That you wouldn't put in what's called an if statement. If I want to compare things, I use two equal signs. Again, you're going to see all of this stuff as we go on. The system is telling me that I'm running out of room on my, because these files that I create are humongous. So what I have to do, let's see. No, not there. That'll work. There. That'll free up whatever I need. Okay. Most of the other ones, hopefully you've worked with at some time or another during your mathematical career. You're going to see them as we go on, guaranteed. Numeric type conversion. I want to make this real simple. These are two different types of variables. One is an int, which means whole number only. One is a double, meaning it can have a decimal place. All right? If I want to do an operation, in this case a multiplication between an int and a double, the system only likes to work with apples and apples. So what it does is it takes this hour's work that's equal to 36. Since it's on the right-hand side of an equal sign, it changes it from 36 to 36.0. It makes it a double. So it's a double times a double. The system does that for you automatically so that it can work with apples and apples, oranges and oranges, and it shows you some of the different kinds of conversions that are done for you automatically. All right? If that confuses you, go back and read it in the book. All right? They also talk about things implicitly being done and things explicitly being done. I don't think you heard these terms last semester. If something is implicit, the computer does it. If something is explicit, you do it. Does that make sense? So if something is done for you automatically, it's implicitly done. All right? If you have to do it, it's explicitly done. And again, you will see that some more as we go on in here. Char I already mentioned. There is an example of a char. I will say this to you, and again, is this something you really need to know? Not exactly, but I want you to hear it. C# uses what's called the Unicode character set. All right? And since it does, you can also put in here Unicode characters. We haven't seen those yet, but we will. These escape sequences, the two that you're going to use 99% of the time are this one, which means give me a new line. That's like carriage return line feed, like you hit enter, \n, and the other one you'll use is \t, which is a tab. You see, I don't know what those are. You're going to use them tomorrow. Those are the two that you'll use almost all the time. There is an example of a Unicode character. Notice it's within single quotes. Even though it's got U0041, since it's got a \u in front of it, this and this are the same. These are the same thing. This is the Unicode value of this. That's all the author's saying right there. Now, do you have to worry about Unicode? Not a lick in this class. Not at all. Just so you've heard it. Strings, again, and I guess I showed it wrong before. String is in a lowercase s. Okay? And notice what we have there. String name 1 is, well, I want to show you. I'm going to grab these and try to copy them to the clipboard. and then do this. Almost sound like a trick question. Will that work? How many think that'll work? Raise your hand. You got to vote one way or the other. How many think that won't work? Raise your hand. Okay, why won't it work? Yes. Now, that will work in C#. That will not work in Java. So when it's a year from now and you're in the class, there you have to say if name1 dot equals name2. That's how you got to do it in Java. That doesn't, this works just fine in C#. All right. There's a lot of ways that you can compare strings. Okay. When you do strings, it does what's called a lexicographical comparison. So if I'm comparing two strings here, I'll put it right here, hopefully you can see that. Mark and Mary. It says same, 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 different. So it stops right there. That's a lexicographical comparison. All right. And again, it's like, is that important? No, it's just so you know what's happening. All right. Strings are immutable. We're going to talk about that tomorrow. When you do a constant, if you look up on the screen here, you use the word const. You used that last semester. This is fully supported in this language. So you use the word const. You tell what kind of variable it is. And then typically you put your constants all in uppercase. That's just convention. So I'm going to ask that you do that. I don't care when you do it if you do it like this or you just run it together. Either way would be totally fine. All right? But I want you to get used to, some of you last semester didn't do that. You'd create a constant and you'd make the first character uppercase or none of them. That's not the way it's typically done. All right? I want you to do it, you know, if you look right here, here's an example. Inches and a foot. And the author even says that makes your program more self-documenting. We're going to be using constants already tomorrow. For instance, I've got a constant that I create called max non-OT. Max non-overtime that I set equal to 40. That means that you can work up to 40 hours and not get overtime. Okay? All right. In enumeration, here's a good example of an enumeration. For lack of better words, an enumeration is a user-defined data type. That's what it is. So I created a brand new data type called day of week. Its only possible values are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. That's all. That's all it holds. So if I wanted to create my own variable that was called, let's say, tree types, and I put in there oak, mountain ash, etc., I could do that. So if you need to have your own type of variable, you can do that using an enumeration. The system actually looks at these as this has got a value of 0, 1, 2, 3, 4, 5, 6. You might find that confusing and say, wait a minute, that's got a value of 0? I want it to have a value of 1. Then all you have to put there is Sunday equal 1, comma, Monday, comma, Tuesday, etc. Then it'll be 1, 2, 3, 4, 5, 6, 7. If you want to do that. And there's the example. And they talk about why you might want to use enumerations. Lack of better words, typically it makes your program a little bit more self-documenting. It's easier to read. That's all. All right, starting tomorrow, you already saw what Readline did. It stopped. Technically what happens with Readline, if you look up on the screen here, I showed you this before, where we use that Readline. So I'm going to do this. I'm going to say string. Oops, it's got to be a little less, sorry. String, first name. And I'm going to initialize it to what's called the empty string. Okay? In fact, I'll initialize it to my first name. All right. Now if I come in here and I type in Readline, first name is you should be able to tell exactly what this program is going to do now. Make sense? All right. The bad thing is, you know, this is kind of bad, and what I mean is, every time I run the program, it's got my name. It's not typically what you're going to want, is it? So what I could do is say this. I think I did that right. We're going to find out. Oh, no, it isn't. What is it? We're going to write a program tomorrow when we do it. I'm just having a brain fart right now, so I can't remember how to do it. So I want to go on. We're also going to learn how to convert. When you go and put something on the screen, when we start doing graphical user interface programs, I'll show you one of the ones we're going to create, okay? Where are we? We won't probably get all of these done tomorrow, but we'll see. We're going to create something, and believe me, this is not at all a masterpiece as far as how beautiful it is. So if you don't like my coloring, use your own. All right? But what you're going to see is when we do this, you're going to start seeing how you can go in and validate stuff to make sure that it works. You're going to learn that right away. Why? Because that's an important part. It's been estimated that anywhere between 70 and 85% of code that programmers write is defensive code. I liken defensive code to car insurance. How many of you in here don't have car insurance? I'm taking it then you all do. Good. All right. How many of you in here hope that sometime or another during your lives you're going to need to use your car insurance? And why? Then why do you have it? I'm asking you. Then why do you have it? Just in case. That's defensive coding. You put it in there in case some nitwit runs the program and doesn't do what you ask them to do. All right? So you're going to learn how to defensively code right away. Here's different ways that you can convert. There's also something called a parse. We're going to go through all of this stuff. And that's it. So let's quickly jump, again, if you've got your book, or if you want to write, wherever you want to write it to, if you would turn, please, to page 93. I'm going to give you these, and that's it for the period. So, number one, when you use a number such as 45 in a C# program, the number is known as, the answer is A. It's a literal constant. So number one is A. Number two, a variable declaration must contain all of the following except. It almost sounds like a trick question. The answer is C, assign value, because you have the word must in there. All right? C, which of the following is true of variable declarations? A is the answer. I don't want you to do that, but it is legal to do that. Number four, I hate questions like this. All right, but the answer actually is D. Number five, I hate questions like this, but I think it's A, but I don't even know and don't care. If they ever put stupid questions like that on your test, I leave them on there, and then just to see what you guess, then I give you credit for them anyway. Why? Because they're stupid questions. All right? Number six. Now notice, you should be able to do this one. Assuming that This is an integer. An integer divided by an integer, so 22 divided by 3 is 7, with a remainder of what? 1. So the answer should be B. And if that makes sense to you, then you're starting to understand mathematical operations already. Number 8 on the next page here. Now, this maybe you might find confusing. All right? The answer to this is actually 7. The answer to this one is 7. Not 7.333. When you do an integer divided by an integer, the system throws away any remainder. Even if it's 7.999999, doesn't matter. Throws it away. So number 7 is B. Number 8, there's no parentheses in here, so you do the multiplication before the division. 6 plus 4 is 10. So number 8 is B, 10. Number 9. Again, kind of confusing, but it's the plus, plus, etc. So number 9 is C, number 10 is B. 9 is C and 10 is B. 11, a variable that can hold true, false is what kind? Bool. Number 12, which of the following is not a C-sharp comparison operator? The answer is A. It actually means something else. Number 13, is 6 greater than or equal to 7? Not any time I've ever checked. So it's false. So 13 is D, false. 14, an int cannot hold decimal places. So 14 is D. 15, believe it or not, the answer is probably D. 16 on the next page is going to be B. If you did just a C there, it would give you 45,000.00. But if you do C0, it means currency, no decimal places. All right. Number 17, A. C sharp. C sharp implicitly chooses for you. Again, when the software does it, it's implicit. When you do it, it's explicit. 18, Unicode is C, a 16-bit character system. 19, now, you're going to get questions like this on the test. This is mainly, again, for you new people, because I've already mentioned this to you guys. You should already be able to throw 2 of these away, because it says here, you're going to hold the word computer, which means it's a string, which means that it can't be C or D. Does that make sense? The good news is now, rather than having to check 4 answers, you only have to check 2. It cannot be B because strings must be within double quotes, so it must be A. All right. And finally, number 20, if you want to compare, the answer is B. Here is your homework. Between now and tomorrow, page through chapters 1 and chapter 2. We went through 100 frickin' pages today, and that was with an hour and a half break. So that was very quick. I get that. Page through this and see if you have any questions. I will try to remember to ask before we start tomorrow. All right, have your computer with you, have it turned on, and have Visual Studio loaded. And we'll get going then as a class. Questions? All right, that's all I got. Now remember, you're not supposed to walk out of here until 55. I don't know why they were walking in here.